Hey everyone, today we're going to look at topic 8, which is the difference of squares. This showed up a few topics ago when we looked at special products. And the way that we did it was actually the reverse of what we're going to see today. This is the way that we saw it then. So if I have two things with opposite signs, so a plus and a minus, your a's are the same, your b's are the same. We multiplied them together, we ended up with a squared minus b squared. Today we're going to focus on going the opposite direction. So we're going to be given a problem that looks like this, and we're going to break it down into that form. Okay. So looking at this first example, you've got b squared and 49. Now the trick to this is that both of these numbers should be perfect squared. And b squared is a perfect square, and so is 49. So you got to try and figure out which numbers create these perfect squares. So following this pattern here, we set it up with our two sets of parentheses, our two factors. You're looking at b squared. Well, b squared here would break into b and b to match that pattern, so b and b. Now if you notice here we have a plus and a minus, so you got a plus and a minus. And then the b squared here breaks down into its square root. Well, the square root of 49 is 7 and 7, so you end up with 7 and 7, and that is the difference of squares. Now, if you take those and FOIL them back together, what you would end up with is b squared plus 7b minus 7b minus 49, and those two things would cancel out, which is why it doesn't exist here. So that's the way those difference of squares set up. For b, you've got 16 and 9, which are both perfect squares, h squared and a squared, which are both perfect squares. Excuse me. And so we break them down the same way. So I got my two parentheses. So here you've got the square root of 16h squared, which is 4h and 4h. This one you have 9a squared, so the square root of that is 3a and 3a. And then they always have opposite signs, so you've got a plus here and a minus there. And that is the difference of squares. So take 1 minute. Work on C and D, and I'll come back in just a second. Okay, hopefully you guys had time to pause the video and give that a try. On problem C, you set up your two sets of parentheses. You've got R and R. The 144 breaks down to 12 and 12. And then you have a plus and a minus. Now for D, it's the same basic idea. Got my two sets of parentheses. 81p squared turns into 9p and 9p. 25s squared is 5s and 5s. And then I've got a plus and a minus, and that is my difference of squares. Okay, those are the basic ones. We can also take this and extend this to some of the ideas that we saw last time. So for problems E, F, we want to look first and analyze. So 27, not a perfect square. 3 is not a perfect square. But if you look at those, they do have a greatest common factor. So between the two, the greatest common factor would be 3g. So I factor out that 3g. Now remember, factoring is division. So 27 divided by 3 is 9. G cubed divided by g to the first. Remember, you subtract your exponents. So that's g squared. And then 3g divided by 3g is 1. Now if you look at this, you've got a 9 and a g squared, which are perfect squares. A 1 is a perfect square. It's 1 times 1. And so you have the difference of squares. So you've got 3g, which has to stay. Then you've got 3g plus 1. 3g minus 1, and there is your factored form. All right, again, pause the video and try F. All right, hopefully you guys had enough time to pause the video and give that a try. So for F, this is a perfect square. X to the fourth is x squared times x squared. 5 and 45 are not, but they do have a greatest common factor of 5. So if I take that out, I've got x to the fourth minus 9 using division. And now, difference of squares. So I've got 5, my two parentheses, x squared x squared. This 9 becomes 3 and 3 with a plus and a minus, and there's your final answer. All right. Final one of these with this type of a setup has 4 terms, and if you remember from a few sections ago, 4 terms use factor by grouping. So I'm going to take my first 2 and group them together, and my last 2 and group them together. Now with factor by grouping, you look for a common factor. So the greatest common factor here is an f. So I factor an f out, I end up with f squared. Sorry, I factor an f squared out. I'm left with f minus 4. On this one, I know that this has to match. So to match this, I've got to take out a negative 9. When I factor out that negative 9, I'm left with it f minus 4. And so if you guys remember, we take the numbers that we factored out, so the f squared and the negative 9, those come together in one binomial. The f minus 4 with repeats comes together as a second binomial, and you got that. Now, the extension from the previous section comes here. This is now 2 perfect squares separated by a minus sign. That's the difference of squares. So you've got f plus 3, f minus 3, and f minus 4, and now that is your final answer. Okay, so these are just some raw examples without a whole lot of context. The last part is we put it into a problem where we may actually use something like this. So this says, Brian is building a deck. The deck is 24 feet by 24 feet, but he plans to change it by reducing one side by some amount and increasing one side by the same measure. The new deck has an area of 512 feet squared. Find the dimensions. So a little bit of a difficult thing to understand what it's asking. Think of it this way. You've got a blueprint. The blueprint is a deck. The deck is 24 by 24, which is a square. But what I'm going to do is I'm going to take my square and I'm going to cut some end or some amount off one end and stick it on the other end. So, not the greatest picture. But let's look at it this way. Here's my square. I'm going to cut this much off and I'm going to add it right there. Okay, so this is getting cut off. It gets added on right there. So what it actually does create is now a rectangle. So here's my rectangle. Well, my original sides were 24 and 24. So what I've done here is I've taken this 24 and I've added some unknown amount. Then I've taken my 24 here, taken my 24 here, and I've subtracted some unknown amount. Okay, so I cut it off on one side and I added it on the other. Now what that tells me is my new area is 512. Well, area is length times width. So here's my length, here's my width. If I take those two things and multiply them together, I've got 24 plus x times 24 minus x. And when I add those together, that equals 512. Well, this is just the difference of squares. So I'm going to expand this out. So I end up with 512 equals. Now you could think of this as FOIL. You could follow the difference of squares. But you take 24 times 24, and if you need to, you work it out. 24 times 24, that's 16. Carry the 1. You got a 9 there, an 8, a 2. A 4, and combine all that, you end up with 576. Okay, multiply here gives you a 24x, multiply here gives you a negative 24x, and then x times x is a negative x squared. And that is still the form for difference of squares. And now you just solve for x squared. There's a couple different methods. We've talked about a few of these. But if I take and get this x squared by itself, I'm going to subtract 576. Okay, so that cancels out. On this side, you end up with 64, or negative 64 equals a negative x squared. You then divide by negative 1, and you've got 64 equals x squared. Well, to eliminate a square, you then take the square root of both sides, and you end up with x equals positive and negative 8. Well, think about what these are. These represent the sides of a figure. You're not allowed to have a negative side measure, so the value there is going to be 8. All right, so we got 8. Now you go back to the question. We decided that x is 8. Well, that's not the answer. The question asks you to find the dimensions. So you take 24 plus 8, that's 32. Take 24 minus 8, that gives you 16. And if you were to multiply those two things, 18. No, 16, bad math. If you multiply those two things together, you will end up with 512, and you could check that, and there's your final answer. All right, so that is the difference of squares. It's just another one of those things to use and get used to it because it shows up quite a bit in these math classes. All right, hopefully that helped out. If you have any questions, contact me online. Otherwise, good luck with your assignment, and I'll see you next time.